Good day to all. This time, I will be discussing to you our Chapter 6 lesson, the rational expressions. A rational expression is a fraction whose numerator and or denominator are polynomials. A rational expression is also called an algebraic fraction. This fraction is said to be well defined if its denominator is not equal to 0. Okay, so here are examples of our rational expressions. So, in fraction form siya, natin numerator and denominator. Ang numerator at denominator kay polynomials. And then, well-defined na sila kung ang ilang denominator dili equal to 0. Okay, example here, number 1, x over 2x plus 4. Dapat si x dili equal to negative 2. Kaya kung negative 2 si x, 2 times negative 2, that is negative 4. Negative 4 plus 4, ang denominator may mong 0. So, dapat dili negative 2 si x para well-defined ang ato ang fraction. Then, another example, x squared minus 9 over x plus 3. So, dili po dapat negative 3 si x. Kaya ma-0 man ang denominator. Then we have example 3, x squared minus 2xy plus y squared all over x plus y quantity multiply to x minus y. So here, dili dapat ang atong x plus or negative y, positive or negative y. Kay kung positive y, so kani ang ma-0 niya. 0 times a number is 0 man, so ma-0 ang denominator. Kung kani pud siya, ang atong x is negative y, so ma-0 pod ni. So, mao na siya nga, dapat well-defined ang ato ang fraction. So, para matawag siya og rational expression. Okay, the two rational numbers, a over b and c over d, where b is not equal to 0 and d is not equal to 0, are said to be equal. That is, a over b is equal to c over d if and only if a times d is equal to b times c. So, mao ni atong giingon nga cross multiply. Equal sila. So, a times d equal to b times c. Okay, examples. We have here 3 over 6 is equal to 5 over 10. Because 3 times 10 is equal to 6 times 5. So, 3 times 10 is 30 is equal to 6 times 5 is also 30. Another example, if x is not equal to positive or negative 5, then x minus 3 over x plus 5 is equal to x squared minus 8x plus 15 all over x squared minus 25. Because, okay, x minus 3 quantity multiplied to x squared minus 25, gana gi-cross multiply, is equal to, kani pod i-multiply dito. So, x plus 5 times x squared minus 8x plus 15. Okay, next, simplification of rational expressions. A times k over b times k is equal to a over b if b is not 0 and k is not 0. Okay, so equal na sila. Kay ang k over k, that is 1 raman. Okay, to reduce a rational expression to its lowest term, factor both numerator and denominator, then divide them by their common factor or factors. Examples, reduce the following in lowest term. Okay, number 1, given here, a plus 2 over a squared minus 4. Okay, notice nga pwede nato ni siya ma-factor out. Okay, sum and difference, diba? Mao ni siya, a squared minus 4 is just equal to a plus 2 times a minus 2. Sum and difference of 2 squares. Okay, then a plus 2, pwede na ito makancel sa a plus 2 sa ubos, and that is 1. So, what is left is 1 over a minus 2. Next, number 2, 3x minus 3y over negative x plus y. Okay, ang GCF nila, ang common nila is 3. When we factor out 3, what is left in this term is only x minus y. Okay? So, diri ato ang paggawas si negative. para mapareho siya sa ibabaw nga x minus y. So, pag ipagawas na to sa negative, x becomes positive, then ang kaning plus y mahimo pong negative y. So, makancel na to silang, mahimo na silang 1. So, nabilin 3 over negative 1, or that is negative 3. Now, let's go to operations on rational expressions. Multiplication and division. Okay, let us recall a over b times c over d, that is just equal to a c over bd. So, pag multiply gani tag 2 fractions, multiply lang nato ang numerator over, multiply po nato ang denominators. Next, a over b divided by c over d. Pag divide gani ang atong sign, mag-divide tag duha ka fraction. Ang first fraction na to a over b, times na nato siya sa reciprocal sa ato ang divisor. So, c over d, mahimo siyang d over c, pero multiply na siya. Since multiply naman na siya, ma-multiply na nato ang numerator a times d over the denominators b times c. Okay, before multiplying or dividing the expression, simplify each rational expression first. So, simplify sa nato ta ay hatamag multiply or divide. Let's go to examples. Perform the operation and simplify. Number 1. We have here 7by over 5a squared b times 8ab squared z over 14y squared z squared. Okay? Since naman tayo mga common, no, pwede nato siya ipagawas una para makancel out nato siya. Ang 7 nato, iyang factor is 1 in itself because it is a prime number. Ang 8 nato, that can be 2 times 2 times 2. Okay? Then, ang ato ang 5 is 1 times 5 lang. Ang atong 14 is 7 times 2. So, sa ilang numerical coefficient, ang pwede na ito mapagawas diri kay 2 ug 7. Since 2 ug 7 man po ang naa sa ubos na pwede na ito ipagawas. Mao man ang common nila. Okay, so mao ning ipagawas na ito si 2 times 7. 2 times 7 po sa ubos sa denominator. So, ang numerical coefficient pa na. Let us see the literal coefficients. So, ang b, mapagawas ba na to? B. Naamay b diri isa. So, pwede na to mapagawas si b. Si y, makapagawas po tag y since naman po y sa ubos. Okay, then ang atong a, mapagawas po na to si a since naman po tayo a diri sa ubos. Then, ang ato ang z, napoy z. So, pwede na to mapagawas ang a, b, y, z. Then, what is left? Dere sa ato ang numerator. Since napagawas si 7, si b, si y, napagawas ang 2 dere. So, nabilin dira 4. Dayon, napagawas si a, si b, napagawas ang kanina man nga b. So, b squared ang nabilin. Then, napagawas si z. So, ang nabilin dito times 4b squared. Over, okay, i-factor na to, ang ipagawas, ang mabilin dito 5. Dayon, ang isa ka a, since napagawas man na to ang isa ka a. Then, ang b napagawas pod, ang y napagawas isa. Since square man na, so nabilin y isa. Then, ang z napagawas na pod, so nabilin isa nga z dito. Okay, so pwede na nato na ma-cancel, that is 1 naman. So, unsay nabilin, that is 4b squared over 5ayz. Next, number 2, a squared plus 2ab plus b squared all over a squared plus ab. Multiplied to a squared minus b squared all over a squared minus 2ab plus b squared. Okay? So, atong i-factor ni sila para ato ang ma-simplify una. This can be factored out as this is a perfect square trinomial. Notice, natay pattern ani. Okay, ang atong factor ana is a plus b times a plus b. Then, deri pod, ang atong makuha nga GCF is a. So, mapagawas na to si a. So, ang mahabilin ni a squared, kay napagawas man isa, a na lang plus, napagawas na ni si a, so b. So, a times a plus b. Then, ang kanideri nga part, this is difference of two squares. So, ang mahitabo pag factor na to ani, sum and difference na siya. So, mo ng A minus B times A plus B. Naapod ni siya sa atong special product and factoring. Okay, diri pod sa ubos. Okay, perfect square trinomial gyapon siya pero negative lang ta. So, ang pag-factor ani, A minus B times A minus B. Okay, since na-factor na nato tanan, pwede na ta mag-cancel out. Kani siya A plus B, makancel din rin ni A plus B. Dayon, ang A minus B, cancel po ta ni A minus B. So, unsa man ang habilin sa ibabaw? Duha ka A plus B. Over, na-cancel naman ng A plus B, o isa ka A minus B. So, A times A minus B ang nahabilin sa denominator. So, pag ma-solve ni, mabalik ta ato dere, over, balik ta dere. So, ang nahabilin, A squared plus 2A plus B squared all over A squared minus AB. Next, addition and subtraction. Recall the least common multiple or your LCM of a set of numbers is the smallest number that can be divided by all the numbers in the set. For instance, the LCM of the numbers 2 and 3 is 6. And we write LCM of 2, 3. That is equal to 6. Okay, let us recall A over B plus or minus C over D. That is equal to A times the LCM of B, D over B plus or minus C times LCM of B, D all over D. All over the LCM of B, D. And we have here A over B plus or minus C over B. That is equal to A plus or minus C over B. So, kung pareha silang denominator, pwede ra na ito madritso plus ang numerator or ma-minus. Pero, og dili gani sila pareha og denominators, kuhaan jud nato siya og LCM or LCD, the least common denominator. Okay? O, pareha ra ang pagkuha sa LCM og LCD. Okay, let us have examples para ma-review na to. Perform the operation and simplify. Okay, given ta ani x squared over x squared minus 1 minus 3x plus 4 over x squared minus 1. That is equal to, so let us find the LCD or the LCM first. So, ang atong x squared minus 1, parihara man na sila. So, parihara ang denominator. So, no need na di ta magkuha LCM. Kay dirita sa atong 2 basta parihara denominator. So, copy lang. And then, i-minus na din nato ang numerators x squared minus 3x plus 4. To simplify further, ang gidistribute ang sign mo aning negative 3x minus 4 over, this is difference of two squares. So, that can be factored out as x minus 1 times x plus 1. Okay, which is equal to, pwede po niya siya ma-factor out. Okay, that is x minus 4 times x plus 1. Okay, giyon sa man nato ni pagkuha. So, para mag-factor out to og trinomial, x squared man ni, ang factor sa x squared kay x ug x. Subutang kada x ug x. Dayon, kani din imong lantawon negative 4. Unsa may factor sa negative 4 para maka-arrive ta og 3. Kung moingon tag negative 2 times 2, dili ta ka-arrive sa ato ang second term og negative 3. So, unsa pay laing factors ni 4? 1 and itself, diba? 1 times 4. So, pwede mat na makaingog 4 minus 1 is 3. So, ato ta sa 4 times 1. Since negative man ni siya, so ang ato ang idako ang 4 may atong butang negative nga sign since negative man atong second term. So, mao nang x minus 4 ato ang factor times x plus 1. Okay, over ang ato ang na-factor na nga x minus 1 times x plus 1. So, cancel na siya. That is 1. So, ang mabilin, x minus 4 over x minus 1. Okay, number 2. 2 over x plus 1 minus 1 over x. Minus na pod x squared plus 1 over x cubed plus x squared. So this time, lahi na sila ang denominator. So we have to find the LCM or the LCD. Okay, so ang ato ang i-factor sa para makakuha tag LCD. Kapi sa taan na, ang atong pwede ma-factor ron kay ang kani siya nga part. So, pwede na ito mapagawa si x squared. Yung GCF is x squared man. So, x squared times x plus 1 ang pag-factor. Okay, since common na to ka na, so ang ato ang LCD na ron, x plus 1 na tapos ang x, nya naman tayo x squared. So, ang ato ang LCD is x squared times x plus 1. Okay, nakuha. Again, kay x plus 1, ding balik naman siya. So, x plus 1 na diha. Then, ang x og x squared, ang x squared, mas dako man siya. So, ang x squared atong kuhaon. Okay, so, mo na x squared times x plus 1 atong LCM. And then, sa ato ang pagkuha sa numerator, kani divide x plus 1. Unsay nahabilin? X squared, diba? Times 2, morning 2 times x squared. Then, x squared times x plus 1 divided by x. Ang mahabilin, x times x plus 1. Moontoy, gibutang x times x plus 1 minus. Dira, minus. And then, sa ikatulo, x squared, x plus 1 divide x squared times x plus 1, 1 na siya. So, i-times dito, so, minus x squared plus 1. Kada ragyapon. Then, i-simplify na to further, 2x squared. Kani mahimong negative x squared. Tayo negative x. Okay. Ang x squared man mahimong x diya i-distribute. So, negative x. Then, we have negative x squared. Distribute ang sign, mauning na negative 1. Over ang atong denominator ng x squared times x plus 1. So, combining like terms, makombine na to. Okay. Ang atong 2x squared minus x squared, that is, x squared na lang ang mahabilin. Then, napamanggit tayo negative x squared. So, 0 na dahil na siya. So, ang mahabilin na lang is negative x minus 1 over x squared x plus 1. So, mani, negative x minus 1 over x squared times x plus 1. Okay, that is equal to, pwede na to siya ma-factor out. Paggawa si negative 1 para mahimong x plus 1 para makakancel ta sa ubos. So, ang final answer na to is negative 1 over x squared. Compound fractions. A compound fraction is one whose numerator and or denominator contains one or more fractions. Steps to simplify compound fractions. Okay, step 1, combine the terms in the numerator and in the denominator by performing the indicated operation so that both numerator and denominator contain a single fraction. Step 2, divide the resulting fractions. Recall a over b over c over d is equal to a over b times the reciprocal d over c, that is equal to a times d over b times c. Example, simplify the following compound fractions. Okay, number 1. X plus 1 over x all over x minus 1 over x. So, this is a compound fraction since ang atong numerator naapod siya fraction o ang atong denominator fraction pod. So, to simplify this one, again, plus man ta, kuha na tog LCM. So, ang LCM nila diha is 1 money over diri. So, x ang atong LCM. X divide 1 is x times x money x squared. X divide x is 1 times 1 money plus 1. Over sa denominator pod, ang atong LCM is x. So, x divide 1 is x money x times x money x squared. X divide x is 1 times negative 1 money negative 1. Okay, so, ang ato ang dividend, copy, divided by the divisor. Copy lang. And then, i-multiply nato na siya, pero reciprocal of the divisor. So, x squared plus 1 over x kani times, reciprocal ani bali. So, times x over x squared minus 1. Okay, to simplify further, kani siya makancel maning x. So, 1 na siya. So, ang nahabilin sa ibabaw, x squared plus 1 over sa ubos, x squared minus 1. Number 2, x cubed plus x squared plus x over x minus 2x squared all over x cubed minus 1 over 1 minus 3x plus 2x squared. Okay, so grabe siya ka-compound atong fraction. Pwede nato ni siya masulat as this one, divided by nga sign. So that ato siyang ma-multiply, kaning atong dividend, ma-multiply nato sa atong reciprocal sa divisor para times na siya, no? So, observe nga ang kanina, na mo ang numerator. Ang numerator diri na mo ang denominator. Okay. Multiply man ta sa reciprocal of that. Then, next, pwede natin ito ma-factor out ang numerators and denominators. So, here, pwede na ito mapagawa si x. Ang common diri tulo ka term is x. So, ang mabilin diri is x squared, x, ug 1. So, gi-factor na si x. Sa atong denominator pod, ang ato ang common sa duha ka term is x pod. So, pwede na to siya ma-factor out as 1 minus 2x. Then, ang diri pod, pwede na to siya ma-factor out. Ang 1, ang yahang factors kay 1 times 1, mauning 1 times 1. Then, ang plus x squared, ang atong 2x squared, yung factors kay 2x ug x. So, mauning 2x ug x. Pero nga nung minus man ni siya. Since ang ato ang middle term is negative 3x man. So, ang ato ang 2 ug 1, dapat ma-add siya niya. Minus man. So, mao na nga negative. Over, kadipod atong x cube minus 1, this is a perfect cube. Pag mahimo na siyang i-factor out, so naman tayo pattern ato atong special product, ma-apply gud na to atong special product diri sa pag-simplify na to compound fractions. So, this can be factored out as x minus 1 times x squared plus x plus 1. So, diba, ang first term minus the second term times square sa first term plus ang atong first term times second term mo ni x plus square of the second term. So, mo na yun ang pag-factor out. So, since na-factor out na nato tanan, makita na nato kung sa atong pwede i-cancel out. So, ang kaning x ug x, pwede siya makancel na. Kani pod siya og kani. 1 na siya. So, kani pod og kani. Ang pwede makancel class ang kung unsa ang numerator na ba siya makancel sa denominator. Dili ka pwede mag-cancel og tapad. Puros numerator, dili pwede ni may cancel puros denominator. Dapat na ay numerator, denominator. So, kaning x ug x, makancel, kana og kana, kani pod kag kani. So, unsa may nahabilin? 1 minus x na lang over x minus 1. So, pwede nato ni siya mapariha kung ipagawas nato ang negative 1 sa isa nila. So, kung atong i-copy numerator, ang kaning ubos may atong ipagawas ang negative 1. So, ang atong ato ang 1 mahimong positive sa sulod. Then, ang atong x mahimong negative. Kaya nagpagawas man tag negative. So, pwede nato na siya ma-cancel na kay pareha na sila, no? Pero, negative ang ato ang sign. Negative 1. Pasabot man ang anay negative 1. And 1 over negative 1, that is just equal to negative 1. Roots of polynomial and the rational root theorem. Let p of x is equal to a sub n, x to the power of n, plus a sub n minus 1 times x to the power of n minus 1, plus and so on. Then we have a sub 2 times x squared plus a times x plus a sub 0. A sub n is not 0. Be a polynomial of degree n is greater than or equal to 1. A polynomial with real coefficients, that is, so we have a sub 0, a sub 1, a sub 2, a sub n, mo sila ang mga real coefficients. And the numerical coefficients, all real numbers, will be called real polynomial. One with rational coefficients will be called rational polynomial. So, kung rational ang kaning mga coefficients na to, rational polynomial ang tawag. One with complex coefficients will be called complex polynomial. So, kung complex po nga itong mga coefficients, tawag po na to complex polynomial. A root of p of x is a value r such that p of r is equal to 0. A root of p of x is a solution of the polynomial p of x is equal to 0. So, kung 0 gani ang ato ang p of x, meaning root na siya sa ato ang polynomial. Okay, ang p of x na to is the polynomial. Okay, example, solve the following. Negative 2 and 2 are roots of p of x is equal to x squared minus 4. So, if you have this polynomial, x squared minus 4, root na to ang negative 2 and 2 nga naman. Okay, because if you have p of negative 2, so meaning atong i-substitute si negative 2 sa atong x, so that is negative 2 quantity squared minus 4, so negative 2 squared is 4. Minus 4, that is 0. And kung ang 2 pod, okay, i-substitute na to sa x, so 2 squared, that is 4 gihapon. Minus 4, mao ng 0. So, kung mag-square kag negative, ma-positive man siya. Kung square pod ni ma-positive gihapon, so mao nang ang resulta 0. So, pag 0 gani ang result nato, meaning, kanin silang duha root sa atong polynomial nga given. Another, negative 2i and 2i are both roots of p of x is equal to x squared plus 4. Okay, kung ato apong i-substitute si negative 2i squared, negative 2 squared is 4. Dayon, ang ato ang I square is negative 1. So, mahimo ra gyapon siyang negative 4. Plus 4 mo ni 0. And also, p of 2i. So, square si 2, 4. Nya, ang square man ni I is negative 1. So, negative 4 plus 4 is 0 ra gyapon. Then, next, we have negative I and I are both roots of p of x is equal to x squared plus 1. Since kung i-substitute na to si negative I ni square, mahimo ra man na siyang negative 1. So, ma-0 ra gyapon. Og diri pod, kung ang I pod, I squared is negative 1 plus 1, so 0 ra gyapon. So, roots na to ang negative I ug I ani nga polynomial. Another, negative 1, 1, and 3 halves are roots of polynomials. P of x is equal to 2x cubed minus 3x squared minus 2x plus 3. So, kamo na bahala mag-substitute ni negative 1, then sunod si 1, then sunod si 3 halves. So, mga roots ni sila ani nga polynomials. Again, to find out nga roots sila, substitute lang ta sa kada x. In substitute si negative 1 una tanan x, then ang 1 na pod and 3 halves. Then, find the real polynomial of lowest degree which has the indicated roots. We have 5 and 7. So, to find a real polynomial, ang ato ang buhaton, minus ta x minus 5 times x minus 7. Na ang solusyon. So, ato na siyang simplify as x squared minus 12x plus 3, 35. Atong gigamitan og FOIL method. Okay, so, mao ni siya ang ato ang polynomial of lowest degree. Nga pwede ani nga mga roots. Then, another 0, negative 1, negative 2, and 2. Ato po ni siyang kuha ang ato ang polynomial as x minus 0, minus yun siya dapat. Then, kani kay negative 1, maaning na plus 1, x plus 1. Kani kay negative 2, maaning na x plus 2, then 2x minus 2. Then, we do the operation para ato siyang ma-solve. Kani siya kay sum on difference, no? Pareha sila. So, that is x squared minus 4. Okay, dayon, x minus 0 is x, money, then x plus 1. So, x times x is x squared, x times 1 is x, money plus x. So, atong gi-foil po ni siya. Foil method, morning natin x to the power 4 plus x cubed minus 4x squared minus 4x. Theorem. The fundamental theorem of algebra. Every complex polynomial p of x of degree n that is greater than or equal to 1 has at least one root in the set of complex numbers. Another theorem, the remainder theorem. If a complex polynomial p of x of degree n that is greater than or equal to 1 is divided by x minus b, where b is a complex number, then the remainder is p of b. So we can find out the remainder kung we will divide the polynomial by x minus b. So example, use the remainder theorem to find the remainder when the given polynomial x cubed plus 3x squared plus 3x plus 1 is divided by x plus 1. So ang atong b diri negative 1, diba? Since ato ang nature is x minus b man. So ang atong b is negative 1. Okay? B is negative 1. And, so if we substitute negative 1 to every x, atong polynomial nga given, negative 1 cubed is negative 1. Negative 1 squared is positive 1 times 3, maaning natay positive 3. 3 times negative 1, maaning negative 3 plus 1. So, ang resulta is 0. Okay, so ang remainder nato pasabot is 0. Corollary factor theorem. X minus r is a factor of a complex polynomial p of x if and only if p of r is 0. So, kung remainder nato 0, okay, so meaning factor si x minus r ni p of x. Note, if r is a root of p of x, then x minus r is a factor of p of x. Next theorem, we have number of roots theorem. A complex polynomial p of x is equal to a sub 0 plus a sub 1x plus a sub 2x squared plus a sub 3x cubed plus up to a sub n x to the power of n of degree n is greater than or equal to 1. So, dapat greater than or equal to 1 ang ato ang exponent, kay kung dili na siya polynomial kung negative atong exponents. Okay, has exactly n roots in the set of complex numbers. The number of roots theorem tells us how many roots to look for. So, ma-determine na to pila ang atong mga roots. If p of x is of degree 4 and 2 roots have been determined, then we need to solve for 2 more. This theorem allows a root to be counted more than once. In general, if k roots are all equal to r, then we say that r is a root of multiplicity k. Okay, let us have examples. Solve the following. Number 1. The roots of the quadratic polynomial x squared minus 2x plus 1 is equal to, so okay, if we factor this out, ang factors niya kay x minus 1 times x minus 1. And that is x minus 1 quantity squared are both equal to 1. So, ang ato ang root is 1 kay x minus 1 man dire. So, ang root niya is 1. In this case, we say that 1 is a root of multiplicity 2. Okay, square man siya. Okay, so 1 ang root of multiplicity 2. Number 2, x times x minus 3 quantity squared times x plus 1 quantity cube has 6 roots. Anong 6 roots man? Unsa man nga mga roots? Okay, we have first 0. Anong 0 man? Kay kung 0 si x, ma-0 man ni sila, diba? So, 0. Then, we have 3. Since kung 3 si x minus 3, ma-0 pod. So, 3. Multiplicity 2 siya kay square man. Then we have negative 1 kay kung negative 1 si x, ma-0 po ta. Then multiplicity 3 siya. Okay, so maotong 6 iyang roots ang 0, ang 3 kaduhaon, dayon ang negative 1 katuloon. Okay, next, 2x squared plus 5x minus 3 has only 2 roots. We have negative 3 and 1 half. Bisa man tagikan ani. So, sa ato pag-factor ani ang mugawas no. 2x minus 1 times x plus 3. So, para makuha na to ang root, i-equate na to ni siya og 0. 2x minus 1 is equal to 0. Makakuha taan na og x is equal to 1 half. Then, x plus 3, equate na to og 0. Makakuha tag x is equal to negative 3. So, moon na nga tong roots kay negative 3 and 1 half. Square man siya, so duha ra pod ato ang roots. Number 4, x squared plus 1 has no real roots but has 2 complex roots, the numbers negative I and I. So, paunsa man ni siya ma-0 nga polynomial. So, kung ang atong x negative I ra or I, kay negative I square is negative 1 plus 1 ma-0 siya. Kung I squared pod, negative 1 plus 1 ma-0 pod. Then 5, a polynomial whose only roots are 2i, negative 2i and 3, multiplicity 2, is p of x is equal to k times x minus 2i times x plus 2i times x minus 3 quantity square, where k is any non-zero number. So, kung magkuha tag polynomial, ato lang siyang i-x minus the roots kung given ang mga roots. So, k ta times x minus ang katong mga roots. Okay, where k is any non-zero number. Another theorem, we have the rational root theorem. Let p of x is equal to a sub 0 plus a sub 1 times x plus a sub 2x squared plus a sub 3x cubed plus up to a sub n x to the power of n, where a sub n is not 0. Be a polynomial of degree n is greater than or equal to 1 with integer coefficients. If p over q is a rational root in lowest terms, the p is a factor of a sub 0 and q is a factor of a sub n. Okay? So, kung naatay p over q, this is the lowest term na nga root. So, ang p factor sa ato ang first term, then ang q factor sa atong last term. Okay, corollary. Let p of x is equal to a sub 0 plus a sub 1x plus a sub 2x squared plus a sub 3x cubed up to a sub n x to the power of n, where a sub n is not 0, be a polynomial of degree n is greater than or equal to 1 with integer coefficients. If p over q is a rational number and either p is not a factor of the constant term a sub 0 or q is not a factor of the coefficient a sub n of x to the power of n, then p over q is not a rational root of p of x. So, kung dili factor si p sa first term, si q sa last term, then ang kaning p over q dili siya rational root sa ato ang given nga polynomial. A suggested procedure for determining the rational roots of p of x is as follows. Number 1, find all the factors, the positive or negative of a sub 0 and a sub n. List all possible rational roots by forming the quotients of the form r is equal to a factor of the constant term a sub 0 over a factor of the coefficient t term a sub n. Okay, number 3, take a specific value of r and divide p of x by x minus r. Synthetic division may be used if the remainder is 0. Then, x minus r is a factor and r is a root of p of x. If the remainder is non-zero, then r is not a root. Case 1, if r is a root, then there is a polynomial q of x of degree n minus 1 such that p of x is equal to x minus r times the q of x. Then, repeat step 1 on q of x. Then, case 2, we have if r is not a root, then repeat from step 3. Okay, to understand better, on how to determine the rational roots of p of x, let us have this example. Find all the rational roots of the polynomial p of x is equal to 2x to the power of 4 minus 5x cubed minus x squared minus 5x minus 3. Then, factor p of x. Okay, this is the solution. Possible roots of p of x. So, let us have the r, ang atong mga factors. So, ang factors nato sa a sub 0, kanin siya si negative 3. Pwede 3 times 1, diba? 3 times negative 1. Or positive 3 o negative 1. Pwede po negative 3 o positive 1. Then, ang ato ang diri sa 2, ang iyang factors 1 and 2, diba? So, pwede puros positive 2 o positive 1. Pwede po negative 2 o negative 1. Okay, so let us list down the possible factors or possible roots. So, pwede ta kaning positive or negative 3. Then, pwede po ta positive of negative 3 halves. Then, pwede po ta positive and negative 1 half. Then, pwede po ta positive and negative 1. Okay, let us try. Okay, let us have x is equal to 3. So, ang atong gikuha is ang positive 3. X is equal to 3. So, we have here p of 3. So, ato siyang substitute sa kada x sa atong polynomial nga given. Okay, ang resulta nato is 0. Thus, kung 0 ang ato ang result, 3 is a root of p of x. Kay 0 man, so ang 3 root siya sa atong p of x. So, ang x minus 3 factor siya sa atong p of x. Kay 3 man, ang pwede factor ang x minus 3. So, we can write, okay, let us divide ang ato ang original polynomial by x minus 3. So, pwede nato ni siya ma-factor out. Pag-divide na to, mao ni siya ang resulta. X minus 3 times 2x cubed plus x squared plus 2x plus 1. Okay? So, ato ni siyang i-let as q of x. Since na natay isa ka factor, ang x minus 3. So, ang q of x na pod, kanina pod ang atong kuhaag mga possible roots. So, ang 1, pwede positive and negative 1. Diba? Then, ang 2 diri, 2 times 1, diba? So, pwede 2, positive, negative 2, o positive, negative 1. So, we can have positive or negative 1 or positive or negative 1 half. Okay, let us try ang positive 1. So, for x is equal to 1, i-substitute na to ang 1 sa x dere. So, pag substitute na to ni 1, ang ning resulta is 5, dili 0. Thus, ang 1 is not a root of q of x. So, dili root ang x minus 1. So, dili siya root. So, let us try x is equal to negative 1. Kung negative 1, i-substitute na to diri sa x, ang mo resulta is negative 2, which is not 0 gihapon. So, dili po root si negative 1 ni q of x. So, dili na to siya makuha root ang negative 1. Then, itry na to ang negative 1 half. Kung itry na to ang negative 1 half, substitute na to dito sa kada x, mo resulta taog 0. Okay? So, thus, ang negative 1 half is a root of q of x. And, kay negative 1 half man, ang ato ang mahimong root x plus 1 half. Ang ganiha, ang 3, nag-0 man siya, so x minus 3. Ang diri kay negative 1 half man, so x plus 1 half is a factor of q of x. And we can write, so mao na ni siya, ang x minus 3 na to ganiha nga factor, o ang x plus 1 half nga factor, so ang nahabilin, 2x squared plus 2 na lang. Aning factor ani. Since, unsa mang pangitaan na po nato ni roots, unsa posible roots ani. Okay, note that negative I and I are roots of 2x squared plus 2. Therefore, so ang atong roots ani kay negative I ug I. Since, kung negative I squared, mahimong negative 1 times 2, negative 2 plus 2, ma-0 siya. Or ang I pod is square, negative 1 times 2, negative 2 plus 2, ma-0 pod. So, root gyud nato pod si negative I ug positive I. Therefore, p of x, ang atong given nga polynomial, kani siya, has roots. Sige, yun sa atong mga roots, ang 3, ang negative 1/2, ang negative I, ug ang I. So, ang ato ang polynomial nga p of x, mao ni siya ang ato ang mga rational roots. So, we have 2 times x minus 3 times x plus 1/2 times x minus I times x plus I. Siya 2 diha kay gifactor man nato ni 2x squared plus 2. So, siya 2 diha. Then, ang kaning dira x minus I times x plus I. Another theorem. A polynomial p of x of degree n is greater than or equal to 1 can be written as a product of linear factors ax plus b or quadratic factors cx squared plus dx plus e, where a, b, c, d, and e are real numbers. P of x is equal to x minus r sub 1 times x minus r sub 2 up to x minus r sub s times q of x, where q of x is a polynomial of degree n minus s. Corollary. If a plus bi is a root of a real polynomial p of x, then a minus bi is also a root of p of x. There is no simple method of determining all the roots of a polynomial. The following strategies are usually tried. So, pwede na makuha ang roots using this. Find all rational roots using rational root theorem. We can also factor into polynomials with lower degrees. Then find the roots of the factors. And we can use also the quadratic expression of the form ax squared plus bx plus c does not factor. We may obtain its roots by, kung walay factor ni, pwede na to gamiton ang quadratic formula. That is x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay, that's all for our discussion on our Chapter 6, Rational Expressions. God bless.